Venus looks beautiful from a distance. Calm, elegant, almost peaceful. Wrapped in a smooth blanket of pale clouds, it seems like one of the most serene worlds in the solar system. But the moment you descend beneath those clouds, the illusion disappears. What waits below is a world of crushing atmospheric pressure, scorching temperatures, relentless volcanic landscapes, and an environment so hostile that surviving there is nearly impossible. The air itself is laced with corrosive chemicals, making Venus one of the most unforgiving places any spacecraft has ever attempted to explore. So how much do we actually know about this beautiful yet hellish planet? As it turns out, far more than most people realize. Let's take a closer look. To understand Venus, we should first zoom out and see where it sits in the solar system. Venus is the second planet from the Sun and Earth's closest planetary neighbor. It orbits at an average distance of about 67 million miles, or roughly 108 million kilometers. Unlike most planets, that distance barely changes because Venus follows one of the most perfectly circular orbits in the entire solar system. In fact, it has the least elliptical orbit of any planet. When Venus swings closest to Earth, it's only about 25 million miles away, making it the nearest planet to us. But here's something that surprises a lot of people. That's actually not when Venus appears brightest in our sky. The reason is simple. During its closest approach, Venus lies between Earth and the Sun, so the side facing us is mostly its nighttime side. Even then, sunlight bends through its thick atmosphere, allowing us to see it. Ironically, Venus shines at its brightest when it appears as a thin crescent. Despite showing less of its illuminated surface, its position relative to Earth makes it dazzling enough to become the brightest object in the night sky after the moon. That incredible brightness has fooled countless people over the years. Venus has been mistaken for everything from mysterious aircraft to alien spacecraft. In fact, former U.S. President Jimmy Carter reported seeing what he believed was a UFO in 1969. Later, analyses suggested the object was almost certainly Venus. He's far from the only one. Throughout history, many UFO sightings have turned out to be nothing more than our brilliant neighboring planet. Since Venus orbits between Earth and the Sun, you might wonder whether it ever passes directly across the face of the Sun, as seen from Earth. The answer is yes, but it happens astonishingly rarely. These transits occur in pairs separated by 8 years, but each pair is separated by more than a century. The last transit took place in 2012. If you missed it, unfortunately, you'll need an incredible amount of patience because the next one won't happen until the year 2117. The reason these events are so rare is that Venus's orbital plane is tilted slightly relative to Earth's. Although Venus catches up with Earth roughly every 584 days, those two orbital paths usually don't line up perfectly. As a result, most people are lucky to witness only one, or at most two, Venus transits during their entire lifetime. Like every planet in the solar system, Venus travels around the Sun in a counterclockwise direction, but unlike almost every other planet, Venus spins the opposite way on its own axis. This backward, or retrograde, rotation is one of its strangest characteristics. It's also unbelievably slow. One complete rotation takes 243 Earth days, the slowest rotation of any planet in the solar system. Amazingly, that's even longer than a Venusian year, which lasts only 225 Earth days. In other words, Venus finishes an orbit around the Sun before it completes a single rotation. Even more surprisingly, while a sidereal day, the time required for one full rotation, is 243 Earth days, a solar day, from one sunrise to the next, lasts about 117 Earth days. That means a Venusian year contains fewer than 2 sunrises. To put that sluggish rotation into perspective, a point on Venus's equator moves at only about 4 miles per hour, or 6.5 kilometers per hour. That's slower than many people can ride a bicycle. Because it spins so slowly, Venus is one of the most perfectly spherical large objects in the solar system, second only to the Sun. Scientists still don't know exactly why Venus rotates backward. One possibility is that a colossal impact billions of years ago flipped the planet over. Another idea is that gravitational interactions with the Sun gradually altered its rotation over immense spans of time. In terms of size and mass, Venus is remarkably similar to Earth, which is why it's often called Earth's twin. It's one of the 4 rocky planets, with a solid surface made primarily of silicate rock. Its diameter is about 7,520 miles, compared with Earth's 7,1918 miles. Its average density is also very close to Earth's, and the gravity at the surface is only about 10% weaker. If you stood on Venus, you would weigh almost the same as you do on Earth. But that's where the similarities come to an end. At the surface, the atmospheric pressure is about 92 times greater than Earth's, roughly the same pressure you'd experience nearly 2/3 of a mile beneath the ocean. Venus's atmosphere contains around 93 times more gas than Earth's, creating an incredibly dense blanket around the planet. Almost all of that atmosphere is carbon dioxide. Add thick clouds rich in sulfuric acid, and you get the most powerful runaway greenhouse effect anywhere in the solar system. That runaway greenhouse effect pushes Venus's average surface temperature to about 867 degrees Fahrenheit, or 462 degrees Celsius. That's actually hotter than the surface of Mercury, even though Mercury is much closer to the Sun. The reason is simple. Mercury has almost no atmosphere, so most of the heat it receives escapes back into space as soon as the sun sets. Venus, on the other hand, is wrapped in an incredibly dense atmosphere that traps heat with remarkable efficiency. As a result, temperatures barely change between day and night. They're nearly the same at the equator as they are near the poles. Venus behaves almost like a giant thermos, locking heat inside and refusing to let it escape. Its axial tilt is only about 3 degrees, so it experiences almost no seasonal temperature changes either. Surprisingly, winds at the surface aren't especially fast. They typically move at only a few miles per hour, but because the atmosphere is so incredibly dense, even those gentle breezes exert tremendous force on rocks, dust, and anything else sitting on the ground. Higher up, though, it's a completely different story. At cloud level, winds can exceed 200 miles per hour, racing around the entire planet in just 4 or 5 Earth days. From space, this makes Venus appear as though it's spinning far faster than it actually is. Those clouds float above the thick carbon dioxide atmosphere and are made primarily of sulfur dioxide and tiny droplets of sulfuric acid. Sulfuric acid is extremely corrosive, and while Venus does experience acid rain, the droplets evaporate long before they ever reach the surface, because the lower atmosphere is simply too hot. The clouds are also incredibly reflective. Only about 10% of the sunlight that reaches Venus manages to penetrate all the way down to the ground. Since the planet is completely covered by these clouds, they also hide the surface from view, making ordinary cameras in orbit virtually useless. Like Earth's clouds, Venus's clouds can produce lightning, although it appears to be much less common. More recently, scientists discovered a massive atmospheric vortex above Venus's south pole, somewhat reminiscent of Saturn's famous polar storms. While the two phenomena look similar at first glance, they're actually quite different. Saturn's polar region contains numerous individual storm systems, whereas Venus is dominated by one enormous rotating vortex. This swirling storm sits roughly 37 miles, or about 59 kilometers, above the surface. That altitude reveals one of the most fascinating facts about Venus. Around 31 miles or 50 kilometers above the surface, the atmospheric pressure and temperature are surprisingly similar to conditions here on Earth. Even gravity is almost identical. The only major problem is that the atmosphere is still completely unbreathable. But inside a properly sealed floating habitat or aircraft, those conditions could actually be remarkably comfortable. Some scientists have even suggested that if humans ever establish a long-term presence at Venus, floating cities high in the atmosphere might be far more practical than trying to survive on the surface. Speaking of the surface, we don't have to rely entirely on imagination. Thanks to the Soviet space program, we have actual photographs taken from Venus itself. In 1970, the Venera 7 mission became the first spacecraft in history to successfully land on another planet and transmit data back to Earth. Earlier missions had all lost contact before reaching the ground. Venera 7 likely tipped over during landing, limiting its observations, but it still managed to measure a surface temperature of about 887 degrees Fahrenheit, or 475 degrees Celsius. A few years later, Venera 8 confirmed that visibility at the surface was roughly half a mile, or about 1 kilometer. Since the cloud deck begins far above the ground, enough light filters through for cameras to see surprisingly well. Then came Venera 9, which returned humanity's very first photograph from the surface of Venus. Later missions, including Venera 10, 13, and 14, sent back even more data, along with the first color images ever captured on the planet. Subsequent orbiters used radar to see through the thick cloud cover and map the hidden landscape in remarkable detail. What they found was extraordinary. Venus is covered with enormous volcanoes. Scientists have identified 167 volcanoes larger than 60 miles, or 100 kilometers across. For comparison, Earth has only a handful anywhere near that size. That doesn't necessarily mean Venus is more volcanically active today. The difference is that Earth's crust is constantly recycled through plate tectonics, while Venus appears to lack that process. Most of Venus's crust is estimated to be between 300 and 600 million years old, leading many scientists to believe the entire planet underwent a catastrophic resurfacing event. According to this idea, heat built up beneath the crust until massive quantities of molten rock erupted across the globe, covering nearly everything in enormous lava flows. Today, about 80% of Venus is blanketed by vast volcanic plains formed from cooled lava. Scattered across those plains are hundreds of thousands of volcanoes of every imaginable size, along with roughly 900 impact craters. Interestingly, almost none of those craters are smaller than about 2 miles, or 3 kilometers, across. That's because smaller asteroids usually burn up or break apart in Venus's incredibly thick atmosphere before they ever reach the ground. And that's where our journey comes to an end. Thanks so much for watching all the way through. If you enjoyed exploring Venus with me, be sure to check out the other videos in this series, where we dive into the fascinating worlds scattered throughout our solar system. Every planet has its own incredible story, and we've only begun to uncover them. There's still so much left to discover. Until next time, thanks for watching.